So we've covered Jupiter and Saturn. Now we're going to talk about the moons of Uranus and Neptune. As with Jupiter and Saturn, both Uranus and Neptune have many moons. As far as we have discovered, Uranus has 5 moderate-sized moons. Again, what we mean by moderate size, these are small compared to the 7 big ones, but they are big enough to actually be rounded by their own gravity. And then, again, as far as we've discovered, it also has 22 small moons. The 2 moons, Umbriel and Oberon, appear to be geologically dead, which makes some sense. It appears that Ariel and Titania have had impacts that have been strong enough to break through the crust and allow ice or water to flow out to fill in low-lying regions, creating features that are similar to Maria, similar to what we talked about on the moon. Now, the heating that has kept Ariel and Titania warm enough to allow for this flow of water is likely caused by tidal heating. Now, Uranus's moon Miranda has a very unique surface. As you look at it, we have some regions that are very heavily cratered. We also have other regions that have shown extreme stresses, so some sort of tectonic volcanic activity. However, when we compare it to the size of the other moons, it is significantly smaller, and yet it appears that Umbriel and Oberon probably are geologically dead. What we think has happened is that Miranda once had an orbital resonance either with Umbriel or Ariel, and due to that it had significant amounts of tidal heating, enough that it actually heated up enough to begin geological activity. Specifically, we think that it was beginning to differentiate. However, that orbital resonance was broken before it could actually finish differentiating, leaving this kind of weird 2 types of terrain. Now, there are some of the small moons that are closer to Uranus than the medium-sized moons. All of these show prograde motion, suggesting that these likely formed in a proto-moon disk around Uranus. Now, many of these moons are very close to each other as they orbit around, and to the point that their gravitational pull actually affects their orbits. Their orbits are chaotic, meaning it is difficult to predict exactly how the orbits are going to move around. We expect that in another couple million years, these moons will likely begin colliding with each other, which will actually be really awesome to see. Alright, here is our 4th clicker question. What do we believe retrograde orbits mean for a moon? A. It was likely captured. B. The moon formed around the planet. C. The moon was ejected from the planet. Or D. No moons have been discovered with retrograde orbits. Go ahead and think about it, and we'll discuss in just a bit. Alright, so the answer is A. So remember, retrograde orbit means that it is orbiting around the planet opposite the way we would expect. According to conservation of angular momentum, we expect that the moons should orbit around the planet in the same direction that the planet is rotating, which is also the same direction that the planet is orbiting the sun. So if we have a retrograde rotation, then it's doing what we don't expect, and our best explanation for this exception is that it was likely captured. So the correct answer is A. Now, the small moons that are beyond the orbit of Oberon have retrograde motion, suggesting that these are likely captured objects. Actually, before we move on from Uranus, something I did want to mention. Something that's kind of fun, the way that the moons of Uranus are named are actually from characters from Shakespearean plays. So if you've noticed some of these names sounding familiar, that might be where they're coming from. Neptune has 13 known moons. It actually has the last of the large moons in our solar system. This is Triton. So again, the 7 large moons in our solar system are our moon, Io, Europa, Ganymede, Callisto around Jupiter, Titan around Saturn, and now Triton around Neptune. Now, Triton has a retrograde orbit, which suggests that it is likely a captured object. So specifically, it is likely to be a trans-Neptunian object. So this is something that is like Pluto, that has an orbit beyond Neptune, but occasionally crosses the orbit of Neptune. Now, Triton does show some evidence of geological activity. Okay, so it has some evidence for ice volcanoes as well as tectonic activity similar to what we see in Europa. Now, the heat that is leading all of this is likely caused by tidal heating, as Triton was originally captured. Now, Triton is actually cold enough to freeze nitrogen. However, on the sunward side, the side that's actually getting hit by sunlight, that nitrogen warms up enough that it sublimates. It goes from being a solid directly into being a gas, which leads to a very, very weak wind traveling from the sun side to the dark side. This will actually catch some of the possible volcanic plumes and lead to this pushing these streaks from the volcanoes that we see. Now, because it has a retrograde orbit, the tidal forces acting on Triton are actually causing it to slowly pull in to Neptune. We expect that in about 100 million years, Triton is going to cross what is known as the Roche limit, which we'll talk about more in a little bit when talking about rings, and that the moon will actually get pulled apart, shredded, and form into a new ring system surrounding Neptune.